In this question, we have to obtain the formula for the electric field E due to a long thin wire of uniform linear charge density lambda without using Gauss law. So very important point here. Use Coulomb's law directly and evaluate the necessary integral. So basically here we have already derived the electric field due to a thin wire. Okay, so that we have done using Gauss law, using the Gaussian surface and everything. But now they are asking us to use Coulomb's law and determine what is the answer. So first of all, we have to draw a long thin wire of uniform linear charge density. So let us draw the diagram first to understand this. So you are having a long thin wire of linear charge density. So let us assume the charge is positive. The only difference between positive and negative will be the direction of the electric field. Rest the derivation is same. Okay, and you have to consider a point P which is perpendicular, which is at a distance of A from the wire. And let us consider a small element dx. So this dx element is at a distance of x from the point which is perpendicular to the point P, and the distance between the element and the point P, let us say this is equal to r. So by geometry we know that using Pythagoras theorem, so r is equal to square root of a square plus x square. Now what happens, due to this small element, okay, the electric field at the point P will be equal to dE, okay, which is along the line joining the two points. Okay, so the DE, direction of DE will be along the line joining P and DX. Okay, so now this DE is at an angle theta, okay, with the vertical. So same way here, what I can do, I can resolve it into two components, DE cos theta. So this angle will be equal to theta, and here I will be getting a DE sin theta. Now if you observe this carefully, now this is an infinite wire. Okay, so I have to integrate the total, to find the total electric field I have to integrate over the full length of the wire. Okay, so when I integrate that, you can see that since this is infinite, from this point there is equal length in the left side and equal length in the right side. So what happens is this dE sin theta for all the left portions will be along this right direction, and the dE sin theta portion for the right portions will be along the left direction. So for every element, okay, which is at a distance of x from the left and the right, you will have a component which will cancel each other. Okay, so when this gets cancelled, if you integrate dE sin theta over the entire length of the wire, over the infinite length of the wire, then you are going to get equal to 0. So we can say that dE sin theta, when you integrate, you are going to get 0. So you are going to integrate from minus pi by 2 to plus pi by 2. What is pi by 2 here? We are going to integrate over d theta actually. So we have not substituted that. We will do it for cos. We are going to integrate over d theta. And theta varies from where? From this point which is going to touch the element which is at minus infinity. And here there is an element which is going to be at plus infinity. So this angle, okay, that it is forming will be theta 1, and this angle will be equal to theta 2. And always angles must be measured in the clockwise, anti-clockwise direction. So anti-clockwise measurement, we will always take it as positive. So theta 2 is equal to plus pi by 2, whereas theta 1 will be equal to minus pi by 2. So when you integrate minus pi by 2 to plus pi by 2, dE sin theta will become equal to 0. And what happens to the cos component? So all the cos components will add. Okay, so they will add, and then the total answer we have to integrate. Okay, so the total electric field you'll get after integrating. So we have to integrate dE cos theta in order to find the answer. So this is our y component. So there is no x component. So the x component is equal to 0. Okay, so the x component is equal to 0. Now here apply your Coulomb's law. So what is electric field from Coulomb's law? So it is going to be dq divided by 4 pi epsilon naught r square. So what is r here? A square plus x square, the whole power half, and then you are going to square it, isn't it? So you square, so that half will get cancelled. So 2 by 2 it will get cancelled. Okay, therefore into cos theta, this we have to integrate from minus pi by 2 to plus pi by 2. So actually I will not write it here right away, because we have to write this derivative in terms of d theta. So then what is dq? Now you know that this particular linear charge of wire is having a linear charge density lambda and over the length dx. So the total charge dq will be equal to lambda times dx. Okay, so when you substitute it here, you get lambda into dx divided by 4 pi epsilon naught a square plus x square into cos theta. Now in this triangle, what is cos theta? Cos theta is adjacent by hypotenuse. So adjacent side is a divided by hypotenuse is a square plus x square power half. Okay, so combining everything, what will you get? So lambda into a divided by 4 pi epsilon naught into dx divided by a square plus x square the whole power 3 by 2. Okay, now what we have to do? We need the terms in terms of d theta, because we have to integrate from minus theta 1 to plus theta 2. Is it? Therefore, we have to convert x in terms of theta. Now from this diagram, okay, can you tell me what is tan theta? Tan theta is adjacent, opposite by adjacent, isn't it? So it is going to be x by a. So I'll just write it here. Tan theta is equal to x divided by a. So from this, what is x? X is equal to a tan theta. Then dx will be equal to a into secant square theta d theta. Alright, this we have to substitute in our equation. So we will be getting integral of lambda. So I can take this out of the integral. Lambda a divided by 4 pi epsilon naught into integral of a secant square theta d theta divided by a square plus, instead of x we will substitute this. So you will be getting a square tan square theta the whole power 3 by 2. Okay, so then lambda a, you take this a also out, so it will be a square divided by 4 pi epsilon naught into integral of secant square theta d theta divided by a can be taken out. So a square into 1 plus tan square theta the whole to the power of 3 by 2. Okay, simplify this. So lambda a square divided by 4 pi epsilon naught secant square theta d theta divided by a square to the power 3 by 2, and here secant square theta to the power 3 by 2. So 2 power will get cancelled. Therefore, I will be having lambda a square divided by 4 pi epsilon naught 4 pi epsilon naught secant square theta d theta divided by a cube into secant cube theta. Okay, so here this a square and this will get cancelled. Secant square and this 1 theta will get cancelled. So therefore, you will have lambda divided by 4 pi epsilon naught a into d theta. 1 by secant theta will be cos theta. So I can write cos theta d theta, and you have to integrate from minus pi by 2 to plus pi by 2. Therefore, your total electric field E in the y direction will be 4 pi epsilon naught a into integral answer is sine theta, and you have to substitute minus pi by 2 to plus pi by 2. Then just substitute the limits. 4 pi epsilon naught a sine pi by 2 minus sine of minus pi by 2. So therefore it will be equal to sine pi by 2 plus sine pi by 2, which is 2. So therefore epsilon naught into a 1 plus 1. So 1 plus 1 I can write as 2. So 2 and 2 will get cancelled. Therefore your answer is E is equal to lambda divided by 2 pi epsilon naught a, which is similar to the result that we got when we used Gauss law. Okay, thank you.